What is R1BIT? R1BIT is an ecosystem for building ESP32-based devices that combines firmware, a cloud platform, a mobile app, and a web interface into a single environment. The project was created to simplify DIY and IoT development and make ESP32 technology more accessible not only to professional embedded engineers, but also to students, makers, educators, developers, and hardware enthusiasts. At the core of the project is custom firmware designed for ESP32P4, ESP32S3, ESP32C6, and ESP32C3 microcontrollers. Once flashed, a device automatically becomes part of the R1BIT ecosystem and can communicate with a cloud platform, mobile application, and other devices without requiring users to manually configure MQTT brokers, databases, APIs, or complex server infrastructure. One of the main goals behind R1BIT was to create a development experience that feels simple and intuitive. In many traditional ESP32 workflows, even basic tasks require multiple libraries, low-level driver configuration, and a significant amount of boilerplate code. For beginners, this often becomes a major barrier to entry. To address this, R1BIT introduces its own interpreted programming language called R1BASIC. The language is designed for rapid device development and automation, without requiring deep knowledge of low-level microcontroller architecture. Its syntax is intentionally straightforward and easy to understand, allowing users to create working projects in a very short time. For example, reading data from a sensor, displaying it on a screen, sending it to the cloud, and visualizing it inside a mobile application can be done with just a few lines of code. Developers do not need to separately build back-end services, design APIs, or create custom communication layers between devices and applications. The platform focuses heavily on hardware integration. The firmware supports a wide range of peripherals and interfaces, including temperature, humidity, pressure, CO2, and environmental sensors, OLED, TFT, IPS, and touchscreen displays, microphones and speakers, I2S audio devices, cameras, servo motors, relays and actuators, GPIO, I2C, SPI, UART, and other communication protocols. Many devices can be initialized automatically using only a few commands. R1BIT also includes a full cloud platform that allows users to manage devices remotely, update firmware, edit and deploy programs, store sensor data, view charts and analytics, receive notifications, access devices from anywhere in the world. A key part of the ecosystem is the mobile application. In addition to device management, it includes a built-in code editor with syntax highlighting, auto-completion, parameter hints, and ready-to-use examples. This makes it possible to write and modify code directly from a smartphone without needing a desktop computer. Another important aspect of the project is stability and security. User programs run inside an isolated execution environment, reducing the risk of permanently crashing or locking up the device because of software errors. Even when issues occur, the system is designed to preserve remote access and recovery capabilities. Beyond development tools, R1BIT is gradually expanding into a broader multimedia platform. Built-in tools are being developed for image editing, video conversion, audio preparation, font optimization, internet radio, media processing for ESP32 displays. These features are especially relevant for modern ESP32P4 and ESP32S3 devices equipped with displays, cameras, and multimedia capabilities. The platform is also optimized for rapid prototyping. Projects that would traditionally take days or weeks to assemble can often be built within hours. This makes R1BIT useful not only for education and experimentation, but also for commercial prototypes, smart home systems, information displays, multimedia devices, and custom IoT solutions. Another major goal of the project is eliminating the complexity of infrastructure setup. After flashing the firmware and connecting the board to Wi-Fi, the device automatically connects to the R1BIT cloud and becomes available in the application. This approach is closer to modern consumer ecosystems, where hardware should work with minimal configuration. The project continues to evolve with the help of a growing community of testers, developers, and makers who contribute feedback, ideas, and new integrations. One of the more unique directions of the platform is communication between devices and developers themselves.
This is the PTT radio.
I am currently building tools that allow users inside the ecosystem to communicate directly through ESP32 devices
This is PTT radio.
using digital voice networking that mimics real radio communication.
Hey, what's up? Hey, what's up?
R1BBIT is more than just firmware for ESP32 boards. It is an attempt to create a unified environment where hardware, software, cloud infrastructure, and user interaction work together as a single system. The project is still in active development, but it is steadily growing into a full platform for building the next generation of DIY and IoT devices.